Welcome back, and today I've got a fun experiment for you. We're going to be looking at pressure at depth and some practical examples of this, and we're going to be using a piece of apparatus called the leaking can. So let's have a quick look at the apparatus. What I've got here is a cylindrical can, and it's got 3 holes drilled into it at different heights. In those holes are corks and glass tubes that are hollow. And what I'm going to do is I'm going to connect it to the tap and fill it with water. And then I'm going to cover up these tubes with my fingers. And before I release them, I'm going to ask you, what do you think happens when I remove my hand? So here goes. I'm going to turn on the tap and let some water in. I'm going to put my fingers over the holes and come back in a few minutes when it's full of water and then release them, and let's see what happens. So I've got my fingers over the 3 holes. What do you think happens when I release them? So let's go. Now the rather nice result you get here is that you get a much longer jet from the bottom hole than you do from the middle one than you do from the top one. What I'm trying to do is put in as much water into the can as leaks out. But you'll notice that the pressure is much higher here than it is at the midpoint than it is at the top. And that's what's causing the bottom jet to go much further. Now, there are lots of practical examples of this. Well, I've had a play with the tap and I've made sure there's as much water coming into the top as there is coming out the jet. So I should be able to leave this without it changing or overflowing. Now, practical examples. Have you ever been diving, sub-aqua diving, or just going very deep in a swimming pool? And you'll notice the further down you go, the more your ears hurt. They begin to pop. In fact, they're being pressed inwards. And this is a pressure effect that's quite nicely demonstrated by this. The other example is when you go flying and you're high up and you're coming down, you're descending to come in and land. And as you come down and down and down, your ears begin to hurt. And this experiment rather nicely explains what's going on. So, time for an explanation. Inside this tank is a column of water. And if you think about it, there's a big stack of water here, and the whole weight of that water is pressing down on this bit here. So this creates a huge pressure. This nozzle, however, only has that much water pressing down on it, and the top nozzle only a very small amount. So as we go deeper, there's a bigger weight of water on top of the lower level, and that creates a greater pressure. So you can see here there's high pressure, medium pressure, and low pressure for what is the same fluid, water. So imagine now you're in the swimming pool and you're diving down deep. When you're quite shallow, there's only a smaller weight of water above you. But as you go deeper and deeper and deeper, there's more and more water above you, more and more weight of water, and therefore there'll be a higher pressure. And that's what pushes your ears inwards. If you're a sub-aqua diver, of course, you breathe high pressure air that hopefully has the opposite effect and pushes your ears outwards, and you can balance out usually at about 6 to 10 meters. But I think most of you will be more familiar with the effect on your ears when you're flying abroad or coming back home and you descend and come into land. If you think about it, you've climbed up quite gently and your ears have had time to respond to the pressure change. The pressure in the cabin actually reduces, and as you go up, your ears usually have time to respond to that change. But of course, when you come down, this is ground level, and up here, you've got very little atmosphere, or at least less atmosphere above you. But as you come down and descend, there's more and more weight of air above you, and therefore a higher pressure. So This is not quite the aeroplane you'd fly in, but up here there's a low pressure acting down because of the weight of the atmosphere. And as you come in and descend, more and more weight of air, and finally at ground level a much, much higher pressure. And of course the cabin pressurizes back to atmospheric pressure at the bottom. So if you think about it, if that happens quickly, the pressure outside your ears is bigger and it pushes them inwards, and that's why it hurts. So most people try and swallow to try and get normal atmospheric pressure back into their mouth to push their ears back out and counterbalance that pressure. So I hope you enjoyed that experiment and learnt a little bit more about pressure at depth. And perhaps now you know a bit more about why your ears hurt when you come down quite quickly in an aeroplane or you go very deep underwater. Looking forward to seeing you again next time.